Today we are going to learn how to graph quadratic equations. How to graph quadratic equations? Well, first you have to plug in some points. So I'm going to go x, y here on a table. Now how I really like to make these is like this. Is instead of having this, I like to go like this and create a gap in the middle where I could put my equation. Now, I plug in 0. And when I plug in 0 and I square it, I get 0. Okay? When I plug in 1 and I square it, I get 1. When I plug in 2 and I square it, I get 4. If I go the other way, -1, when I square -1, I get 1. When I square -2, I get 4. And you'll notice, okay, that these values right here all repeat. Okay? What's happening here is it's creating a curve, a repeating curve, okay? Now, our vertex in this one is 0, 0. So when we graph this, we get this. Notice I started from the dot on the bottom, not on the top, and went all the way around. That is our quadratic curve. And this is what we like to call the parent function. Every graph that we ever have, or kinds of graph we have, will have a parent function. This one is the parent function for quadratics. Now we are going to graph y equals 2x squared. This is not the parent graph because the parent graph is y equals x squared. So we plug in some points. I plug in 0. I get 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. -1. 2 times -1 squared is 2. -2. 2 times -2 squared is 8. And you'll notice again, this was my vertex. The -1 and the 1 are repeaters, 2 and -2 are repeaters. We go to graph this, okay, 0, 0, and then -1, 2, and 1, 2, and then -2, 8, 1, 2, 3, 4, 5, 6, 7, 8. Then we draw our line. Again, I start from the bottom. I don't start from the top and wrap around. Okay? And there's the graph of that. Notice it's stretched vertically, and that's because the A is greater than 1. Once the A is greater than 1, it stretches vertically, or I call it narrows. Now we're going to graph y equals -1/2 x squared plus 3. So I plug in 0. Zero squared is 0 times 1/2 will be 0, so plus 3 is 3. 1 -1/2 times 1 squared plus 3. That'd end up being -1/2 plus 3 would give me 2.5. 2 -1/2 times 2 squared. That's going to give me -2. because 4 times negative 1/2 is negative 2, plus 3 is 1. And again, these repeat in the other direction, so it's going to be 2.5 and 1. Go to graph this, 0, 3, 2.5, and then 2, 1. Negative 2, 1. And you'll notice this graph got wider. Okay, as I said, the last one, they got skinnier if it's larger than 1. Well, if A is less than 1, it gets wider, just like our absolute value graphs. And that's the graph of that equation. Now we are going to graph 2x squared minus 8x plus 6. Now, this isn't as easy as the ones before because all we did was we knew the vertex was 0 because there was no b value. When there isn't, we have to look for vertex form. Vertex form, or the axis of symmetry is what some call it. Is your negative x equals the negative b over 2a, where this is the x value of the vertex. So in this case, okay, our x value of this vertex is going to be x equals a negative 8 all over 2 times 2, which is going to give me 8 over 4, or 2. So our middle value will be 2 because that is the vertex. And then we'll step out from there, 3, 4, because we only need 5 values to graph. 1, 0. Plug in our values. 2 times 2 squared minus 8 times 2 plus 6. That gives me 4 times 2, which is 8, minus 16, which is negative 8, plus 6 is negative 2. Plug in 1 times 1 plus 6. End up with 2 minus 8, which is negative 6, plus 6 is 0. Plug in 0, and you get 6. So 0, 6, because this is my vertex. I go to graph, I get 2, negative 2. 1, 0. 3, 0. 0, 6. 1, 2, 3, 4, 5, 6. Boom. Draw my lines for my quadratic. And again, you'll notice it's skinnier than the parent because a is greater than 1. Now, why they call that the axis of symmetry? Because that is a line that if you graph the x equals 2, it would be this dotted line that I'm making right down the middle of that. And if I took it, I could fold the graph on top of the other side. That's why they call it the axis of symmetry. Okay, now we're going to graph 2x squared plus 6x plus 3. Again, this has a b value so that we know that we're going to have to find the axis of symmetry, or the x value for the vertex. So x equals negative 6, because negative b over 2a, or over 2 times 2, which is going to give me negative 6 over 4, or negative 3 halves, which is negative 1.5. So that is my x value, negative 1.5. Now we'll need to step out the same amount of distance in each way. So I'm going to go to -1, 0. Over here I'm going to go -2, -3. And that's a distance of 1/2. That's a distance of 1/2. This is a distance of 1.5. That's a distance of 1.5. So we're good. As long as it's the same distance on each side, it'll work out. We go to do this, and we get 2 times -1.5 squared plus 6 times 1.5 plus 3. And we get -1.5. Plug in -1. End up with 2 minus 6, which is -4, plus 3, which is -1. Plug in 0. And you get plus 3. So these repeat in the other direction. Graph it. Okay, we go to -1.5, -1.5. And then -1, -1. -2, -1. Then 0, 3. -2. We graph this. And there you go. And again, the axis of symmetry, if we were to graph that, that would be the folding point for the graph. Now we have max and mins. And we need to know that of the graph just by looking at it. And we can tell by the A value here. Right there. Okay? We can tell by that. And what I mean by that is, okay, if that is positive, this is the way the graph looks. Okay? And if that means that there's a minimum because it has a valley. Okay? If the A is negative, like down here, that's the way the graph will look. And it has a peak, so it has a maximum. So, minimum if A is positive, maximum if A is negative. So in this one, there is a minimum because A is positive. So we have to find the vertex. And that's your x equals -b over 2a, or x equals -18, or negative of a -18 will be +18 over 2 times 3. And that's going to give me 18 over 6, or 3. Now we plug in 3 to get our y value. Three squared minus 18 times 3 plus 2, 20. And you end up with y equals -7. So our vertex, or our minimum, is 3, -7. And they actually call this the minimum value because it is the actual height. Alright, now we'll look at this one and tell if it has a minimum or maximum. It has a maximum because it is negative. The graph will be shaped like this, therefore we know it's a maximum because it has a peak. And we'll go x equals a -6. Oh no, negative 0 over 2 times -6, end up with 0. Plug that in to get our y value, and we get -6 times 0 squared minus 1, or -1. So our vertex is 0, -1, and our maximum value is y equals -1.